Hey guys, Jason Matthew here from Trinidad and Tobago, and welcome to our new segment called Biochem Bloopers. Basically, we're going to be looking at exam questions and looking at students' responses to these questions. It is meant to be a constructive exercise where we learn from the mistakes of others. So today's question is a classic enzyme question. Explain the effect of increasing temperature on an enzyme catalyzed reaction. And if you saw the other two videos that I did on enzyme bloopers, you know what that pause button means. That's right. Pause for a cause. Write down the question if you have to, but definitely attempt to answer the question before you move forward. So if you need to go to your textbooks, go and check my videos and so on, please do so. But whatever you do, do not go forward until you have answered the question. Believe me, it will work and it's beneficial to you. It will help you learn better. So please go and try to get an answer before you move on. Now the good news is that this question, it's a classical question and students they look forward to a question like this. They do very well. So I don't have much bloopers on this particular question. Now, if you look at this student here, she had some points, but she missed some, and then her graph was a little off. So let's look at it. So she mentioned about the optimum temperature, and she said between 37 to 40 degrees. Yes, normally for the enzymes in the human body, around 40 degrees is the optimum temperature. All right, so she correctly said that. Now she made a little mistake here, and I think this is just due to stress of the exams. I know I would like to think that she knows that enzymes are not protons, and what she really meant to write here was proteins. And again, it's just exam stress, so she was not penalized for this per se, right? And there's the other stuff that she was missing, and so on. Now, if you look at the curve here, this curve looks kind of symmetrical, and that's incorrect for a temperature graph that looking at the enzyme catalyzed reaction. The good news is that she labeled the axes correctly. She said rate of reaction on the y-axis, temperature, but she should have put the units, all right? Although it's not drawn to scale, all right, which is fine, you need to put your units, all right? And then she spoke here about optimum temperature, but if you look at the curve here, there's no way that you indicate that this here is you should write the words optimum temperature. But I think the biggest problem I have with this curve is that temperature does not produce a symmetrical curve. In other words, this distance from the optimum temperature to here is not the same distance as from the start to the optimum temperature. That is incorrect. In fact, x should be significantly less than y. Distance x should be significantly less than distance y. So as soon as you pass the optimum temperature, your curve should come right down like that, and we'll explain that in a little while. Alright, so this distance should be much less than this distance here. So it should come down about here. So now that might sound simple, but you wouldn't believe how, it's like instinctively that you will do a symmetrical graph, and it comes like a reflex action. So please go to your textbooks. They're going to have some nice diagrams there. I have one or two in the Enzyme podcast, and practice drawing this curve. It's more difficult than it looks. Huh? So if these are the only points that you spoke about that we have covered so far, well, I should tell you that your answer is in some trouble because you're still missing some very valuable points. So if this is all you have and you have nothing else, you're checked off and this is all you have, I would recommend that you go back, you read some more, and supplement your answer because you're still missing some points before you go ahead. So I'm giving you a second chance, so to speak, to see if you can get all the marks at the end, because the goal here is to try to get all the points. Now, I'll give you a hint. Some students, the downfall in this question is that they immediately go to the optimum temperature part, and once you pass that, you have denaturation, and they really focus on that. But remember, there are two sides to this story. All right, the enzyme is not denatured immediately. All right, so for as you gradually increase temperature, the rate of reaction is going to increase. As a rule in chemistry, for every 10-degree rise in temperature, the rate of reaction approximately doubles. So that's a kind of general rule in chemistry. Now you might ask, well, why is that? Well, what's happening here is that when you increase temperature, you are essentially increasing the kinetic energy of the system. And if you remember from your little physics, you would know that kinetic energy means movement. And what we are having here is that you are having collisions taking place between substrate molecules and the active site of the enzymes. And because there's an increased collision frequency between substrate and active site, you have an increased rate of reaction. Now, temperature not only increases the collision frequency, it also increases the number of substrate molecules having activation energy. And let me see if you remember your little chemistry and stuff and what we did before. Define what is activation energy. So you should be correctly saying that activation energy is the minimum amount of energy for the reaction to occur. Now this increase in rate of reaction, the rate of the reaction is going to increase until it peaks at an optimum temperature. So in other words, that highest point on the curve, the maximum rate, all right, that the enzyme is at, the corresponding temperature to that maximum rate is called the optimum temperature. This is the maximum rate of reaction for the enzyme. The temperature that corresponds to that, the highest point on your curve, is called the optimum temperature. So guys, if you all had all those points, you're almost there, all right? But again, that was the increasing part. Now we need to talk a little bit about the denaturation part. So you're almost there. So I'm hoping that you have some points for denaturation now. So once you pass this optimum temperature, you have denaturation of the protein. And in this case, it's an enzyme. So you have denaturation of the enzyme. So what does that mean? Now remember, as I was saying before, you have increasing temperature. Therefore, the kinetic energy system is increasing. The bonds are therefore in the protein is keeping the bonds that are keeping the tertiary structure together is vibrating. And what we say is that as soon as you pass this optimum temperature, the weak bonds such as the hydrophobic interactions and the hydrogen bonding and so on, they tend to break. And most importantly, once you have breaking of the hydrophobic interactions, you're going to lose the tertiary structure. And what that means is that you're going to lose the shape of the active site. And therefore, substrate will no longer fit and bind to the enzyme to form the enzyme substrate complex. The rate of reaction is going to quickly decrease. Now, there's a reason why it decreases quickly. If you went to my videos, you would know that this denaturation is a cooperative process. The breaking of the bonds is a cooperative process. That as soon as some of the bonds, they're going to resist this breaking. But once you cross the optimum temperature, and as soon as some of the bonds start to break, all of the bonds break quickly. So it's a cooperative process, and that's why as soon as you pass the optimum temperature, the rate of reaction, it just falls down, it precipitates quickly, and that's why your curve is not symmetrical. And just to, to seal the deal, so to speak, just to finish it off as a perfect answer, you should draw a figure showing the effect of temperature on an enzyme catalyzed reaction. So you're going to be putting rate of reaction on the y-axis, and you're going to be putting temperature on the x-axis. Remember to give units. Also, the curve is not a symmetrical one, The effect of pH will give you a symmetrical curve, but for temperature, it is not a symmetrical curve. And also on your curve, label the optimum temperature. And once you have those things, you're there. Full marks, guys. So how many of you all got full marks? I'm sure a lot of you all out there. Please send me some feedback. Tell me if you got all these points on your first try. If so, excellent job. If you missed some, that's fine. It's a learning process. What I would do is say, give it a rest, come back in 2 days' time, and answer it again and see if you got all the points that time. And let me know. Tell me about your progress. And if these videos are helping you all out, please hit the like button. And if you haven't subscribed yet to the Biochem GM channel, what you're waiting for? Go hit that subscribe button. And as usual, guys, thank you for your support. More videos coming soon. Take care, guys.